Here we have a word problem using direct proportionality. So when pedaling a bike into the wind, a force is exerted upon you. The force is directly proportional to the wind velocity squared. So we know that we have the force is directly proportional. So we have our K, our constant of proportionality. So the wind force F is directly proportional to the wind velocity, and it says squared. So it's going to be K times V squared. There's our equation for direct proportionality. We're not given a couple points to be able to solve for what K is, the constant of proportionality, but the force is directly proportional to the wind velocity squared. And we want to figure out if the wind velocity doubles, the wind is feeling twice as heavy on you, how much does that wind force go up? So how is the force affected if instead of having just a regular V getting squared, we have double the initial amount of wind velocity? We have 2 times our wind velocity. How does that affect the force? Well, we have K, and we're going to square it, each of these terms. So 2 squared is 4, and then we have V squared. And we square both of those terms. So the force is going to be 4KV squared. So the question is, what's the difference between the initial equation with a regular V in it and then the equation we get when we double that wind velocity? We did 2 V's and we squared it. So we went from KV squared to 4KV squared. So what happens? How much does the wind force go up? It quadruples. They're directly proportional, but it's to the wind velocity squared. So having double the wind velocity quadruples the wind force. So we go from KV squared to 4KV squared. Doubling the wind velocity doubles that wind force that you feel, or quadruples that wind force you feel against you.